All right, so we're going to draw our cladogram together. And what we're going to do here is we've got this table of traits or derived traits over time. And we want to take these 7 different organisms and build a chart that maps out how these organisms possibly are interrelated to each other. Okay? And we say possibly because in a cladogram or a phylogenetic tree that you're being drawn, all that we have is the evidence in front of us. These are things that we call having hair or not, having lungs or not, bony shell or not, grasping hands or not, jaws or not. We don't have any DNA evidence that we're using. We just have this piece of information. And in true life, when we draw these phylogenetic trees or cladograms to show the interrelatedness of organisms, see how close they are, how far apart they are. Remember, this is just a hypothesis. It could change if we have more information. But given only this information, can we come up a way to map out how possibly these organisms are related or not related with each other? The best way to do that is through a cladogram using these traits here. So, the first thing I do, okay, is I'm going to draw this line right here. We tend to draw a line like this. Why? Because we're going to go up, okay? And this, of course, is going to equal, the lower we are is a kind of a timeline, all right? And so we start in this low area here, and this is, of course, longer time ago, all right? These are not as far ago. So basically, this bottom line is a time factor. Although we're not going to map out and try to figure out how long ago these things happened, we definitely have a rough timeline down here when you think about this. So this down here, you don't have to write this, but this is essentially mapping out some kind of time factor. But in a cladogram, we don't use any evidence of time. We don't see how fast or how slow something evolves from one organism to another. But we use the idea that this is, older and younger, okay, if you want to think of it that way. Okay, so that's a time factor there, and I don't think you need that there, but I'll leave that there anyway. Okay, now, what we're going to do here, this, of course, is pretty much where we're at now, and of course, we're going back in time when these individuals, of course, evolved. Of course, we understand it's a mutation that created a new trait. It was a selective pressure that selected that mutation to grab a hold in the population. So the first thing you do is find your outgroup. You want to find from these lists who's got the least amount of traits. Yes? The lamprey. So what I'm going to do, all right, is draw this up here. So I'm going to do this, and this is the lamprey. Okay, why did I start there? Well, I'm using something called logic. Sometimes they call it Occam's razor. And we're going to use basic logic. And the logic here is that the most simplest explanation is probably the what? Probably the best or the most correct here. Nobody was living back during these changes, but we're just going to use logic. So the idea here is that we're going to start with the most simplest of all animals with the least amount of traits, and then we're going to build on that and see how organisms develop them over time. Okay, so when I look at the next one, I want to find one that has the second least. Caitlin's going nuts here.
Pike.
Okay, the pike, all right? And so the pike has only jaws, okay? Now, interesting enough, all the other organisms have jaws. So what does that mean? Think logic. It was probably the first one to develop from the lamprey into jaws. So watch what I do here. Okay, I'm going to write jaws. So right here, I mark this here. That represents a new trait, a new mutation that was selected for. And I'm going to put jaws right here. So unlike a phylogenetic tree, we actually label where the new allele possibly developed. I say possibly. Remember, this is a hypothesis based on data that I have. Okay, so we see that the pike is next. And so I draw this line all the way to the top, and I write the pike. And if you read it right now, what's it say? The pike, the lamprey, has none of the traits that we're testing. What is a pike? To get to the pike, I have to go through here. It developed jaws. Okay. Now, who else has the second most? Okay. Okay, and you would say the lungfish. It's all about Caitlin today. And look at the lungfish. They developed, guess what? Lungs. Okay. My gosh, Oshkosh. So, the next trait, I don't know if I have enough colors. I'll just keep them in red. So the next trait I write here, I write lungs. Lungs were developed. Of course, it's more than one mutation. And who's got the lungs and the jaws? The lungfish. Okay? So, and you can read it. To get to the lungfish, it had to do what? Develop some jaws and then lungs. And look at it. The lungfish has what? It has jaws and it's got lungs. All right, looking at this now, I can see possibly who's next. Well, now we have some choices here. You've got the turtle with lungs and a bony shell. Weird though, nobody else has got a bony shell. It is doing its own thing. Okay? Now, if I look at the next next one here, after looking around, I got turtle, I've got gorilla, wolf. What's the wolf have? It's got jaws, it's got lungs, it's got hair. Okay? And you can see that there's other things with hair. Okay? Nobody has got the bony fish. Okay? A bony shell, sorry. I don't know where the bony fish came from. All right? So, to me, the turtle is next, but I gotta make some sense of this. Okay? So the turtle, okay, has jaws, lungs, and now it has the what? Bony shell. Here's my problem. Now watch what happens. This is not correct, so don't write this down and be angry that you messed up your perfect cladogram. Okay? If you were to do this and say, okay, I'm a robot, this is the bony shell. Don't write this, okay? And you thought that's the next trait, and you put this incorrectly to be the turtle. I like turtles. Okay? Doesn't that mean everything upstream that developed that was more complex? Remember Occam's razor, go from the simplest to the more complex. That makes sense to do it that way. Wouldn't that make the human, if it's up here, have a bony shell? So we can't do it that way, correct? So here's what we do in this case. The bony shell can't be down here because if humans are the most advanced, or if they're over here with the wolf in here, they would have a bony shell if you read it. So I think, again, this is a hypothesis, a best guess here, that I'm going to make this branch off. Watch. I'm going to branch this off to the turtle. And watch what I do here. I'm going to make the what? There is its allele, the what? Bony shell happen here. There's a common ancestor I think the lungfish and the turtle have. And if I look who's next, hey, the wolf has jaws. It's got lungs. It doesn't have any grasping hands. Okay? And has hair. So for me, the next individual here is the wolf. What does it have that the other three have? The other two organisms left. Yes? Yeah. A little break in the voice. I liked it. So, we put here, hair. And if I'm putting it here, what does it mean? All the other individuals upstream have to have jaws, lungs, hair, but not bony shells. Okay? Now I got ape left, or the gorilla, I should say, and the human. Well, the ape and the human have the greatest number of traits, but what's different about them? Yeah, the human has got the grasping hands, but the gorilla doesn't. So the gorilla...
It
It definitely has them, okay? So they're exactly the same. Okay? So in this case, based upon this piece of evidence, I can do this. Put the gorilla, oops, Christmas in July. I can put the grasping hands here. Sounds like a song for a new artist. Okay, grasping hands. Okay. So this is the gorilla. And then, of course, at the end here is the human. And so if you were to read your cladogram correctly, okay, going from the older organisms that have less what? Traits to evolutionary younger organisms that have more traits. We're using just our logic. More simple. Back in the day, there was less mutations that occurred, less alleles. We go from simpler to more complex. All right? Now, there are some adjustments I can make to this. Remember, this is our best guess based on this information. When this information changes, hey, a new fossil is found, new piece of evidence. Sometimes our phylogenetic trees and our cladograms change as well. This is not ever finished unless we're dealing with DNA of living things. That's definitely finished. We know the DNA is the imprint of the code. But, just so you understand, I could have the same correct cladogram by changing something. I could have the turtle over here and the lungfish. I could switch these and it wouldn't change, as long as I have the bony fish where? On the turtle. Which part of the fork I write doesn't matter, right? If I put the bony fish here and lungfish, it'd still get jaws, lungs, bony fish. And if lungfish is here without the bony fish, it would read the same way. Bony shell, I keep saying bony fish. Okay, that's going to be some comments on YouTube. You just can't say bony fish. What's bony? Okay, all right. I don't know why it's stuck in me. All right. Any case, same thing with what? Couldn't I put the gorilla here and the human here and the gorilla here? It wouldn't matter. And how do you know you're right? What does the turtle have? It has jaws, lungs, bony shell. Okay, and yeah. I have issues, and I'm tall. And we have the what? Lungs, jaws, bony shell. To me, no bony shell. Where am I? I was doing the turtle. Yes, I can do this. Jaws, bony shell, okay, and lungs. I can do this. So you can read them. So to get to the wolf, this is what they have to have, okay? These 4 traits. Okay, so quickly, these questions I wanted to review based upon our drawing here, and then we're done today. So just listen through. So based on these, which species would be the outgroup? Which species is mostly not related to the others? Yes?
Lamprey.
The lamprey. It's got less what? It's got less of the same allele. So this is the outgroup. The outgroup is the group of individuals, in this case, one species, that has the least shared genetic code, least shared alleles. Therefore, evolutionary, it is the least related to the others. All these others are more interrelated. This is the outgroup, okay? Which 2 species are most closely related? Yes, Lucy.
The gorilla and the human.
I could accept that, because they share exactly the same type of what? Alleles. But I can, who else is closely related? Yes?
The lungfish and the turtle.
Yeah, but I'd have to say that the gorilla and human is the best answer because they have them. But these are also closely related, but not as closely related as these 2, because these have exactly the same. So your best answer is these 2, but always look at a fork, okay? They share a common ancestor. And guess what? So do gorillas, okay? That's a great question there. Are pike more closely related to lungfish or to gorillas? Are pike more closely related to lungfish or gorillas? Lungfish. What separates a pike and a lungfish? One allele difference, lungs. What separates pike from a gorilla? 2 more alleles that it has to evolve into. So it is more evolutionary related to lungfish, based on having less alleles between them. Okay, which of the derived traits came into existence before bony shell? Lungs and jaws. List all the derived characteristics in the table that would have been present in the ancestor to gorillas, wolves, and humans. Ancestral. That would have been present in the ancestor to gorillas, wolves, and humans. What's the ancestor to the gorilla, wolves, and humans? Where are we? So what's the question again? That's the spot we're talking about. List all derived characters that would have been present in the ancestor. Okay? Well, the ancestor to these three, this is a great little question, is right here. Does that make sense? This would be the ancestral species for who? The gorilla and the human. But this would be the ancestral species of all three, correct? So therefore, which alleles or characteristics would have been present to all three? Would grasping hands be present to all three? No, it's only present to these two. So it would be what? Hair, lungs, and jaws. Circle the most recent ancestor of the wolf, gorilla, and the human. The most recent ancestor to the wolf, gorilla, and the human. We did that. Okay? All right. Not difficult, a little different. Okay? By the way, this is an example of divergent evolution, going from simpler to more complex. Now, what if I had something like this? What if hair developed over here again? It didn't. The lungfish doesn't have hair. It'd be the hairy lungfish, okay? Which is kind of weird, okay? But wait a minute. If you had hair here and here, wouldn't that be convergent? Okay? Doesn't mean that they're interrelated. It's just that they might have the same, what? Selective pressure. Okay? All right. Hope that helped. Rest of the time is yours. Whatever's left.